Hey there. Ever noticed how your phone can translate a text message from Spanish to English in a flash? Or why some AI translations sound more natural than others? Let's unravel the science behind neural machine translation and how researchers are making it smarter, more precise, and even human. Back in 2016, a team led by Rico Sennrich and Barry Haddow asked a big question. What if we gave AI translation models more than just words? Traditional neural networks treat language like a string of random symbols, but human translation relies on grammar, syntax, and context. Their breakthrough: they fed the model linguistic features, like sentence structure, part-of-speech tags, and even punctuation, to help it understand meaning better. The result? Translations that were more accurate and less robotic. Here's how it worked. Imagine teaching a child to speak by only showing them words. They'd probably mix up sentences or miss the nuance. But if you also show them how words fit together, like verbs follow subjects or questions end with a question mark, their understanding skyrockets. That's exactly what these researchers did. They didn't just feed the model raw text. They gave it tools to parse language like a human. Let's break it down. Traditional translation models would take a sentence like "Je mange une pomme," French for "I eat an apple," and convert it to "I eat an apple" by matching words. But the new approach added layers of insight. For example, the model learned that mange is a verb, une pomme is a noun phrase, and the sentence structure follows a subject-verb-object pattern. This helped it handle tricky cases, like idioms or grammatical differences between languages, more naturally. The results? A 12% improvement in translation quality on benchmark tests. But here's the kicker: this wasn't just about accuracy. By embedding linguistic knowledge into the model, researchers made translations smoother, more context-aware, and less prone to errors. It's like giving AI a dictionary and a grammar book, so it doesn't just translate words but meaning. So why does this matter? Well, imagine a world where AI doesn't just swap words between languages, but understands them. Whether you're translating a legal document, a medical report, or a casual message, this tech makes communication across languages more reliable and human-like. It's not just about speed, it's about depth. Now here's where things get even more fascinating. Behind every great translation model is a mountain of carefully curated data. Let's dive into how researchers are refining that data to make AI smarter. Imagine you're sorting a giant pile of books. Without labels, it's chaos. But if you categorize them by genre, author, or even reading level, finding the right book becomes easy. That's what these researchers are doing with AI training data. They're creating smart labels to help models understand context better. Here's the cool part. They use a special reward model, like a digital grading system, to evaluate parts of their training data. This model gives rewards based on quality, then sorts the data into 4 buckets or quartiles. Think of it like rating a movie on a scale from 1 to 4 stars. High-quality data gets a 4, and lower-quality stuff gets a 1. This helps the AI focus on the best examples when learning. But they didn't stop there. They added even more labels to give the model extra context. For example, a prompt like, "How do I calculate a factorial?" could go in the math bucket, while "Write a Python function to check a palindrome" would land in code. These domain labels act like signposts, guiding the AI to use the right knowledge for the right task. Then there's the task label. This tells the model what kind of job it's doing. Is it translating text? Explaining code? Writing a story? By tagging prompts with categories like translation, code generation, or creative writing, the AI learns to adapt its response style. It's like giving a chef a recipe card. They know exactly which tools and techniques to use. And here's the magic. When the model doesn't have clear labels, it uses another AI, like Command R+, to figure it out. They even gave the annotator model clear instructions, like, if a prompt is about biology, tag it sciences. If it's about coding, tag it code. It's like teaching a robot to sort laundry by color and fabric type. Why does this matter? Well, imagine asking an AI to explain quantum physics. Without the right labels, it might mix up technical jargon with casual chat. But with these smart annotations, the AI can deliver a clear, accurate explanation. No confusion, just precision. So why does this matter? Because these advancements aren't just about better translations. They're about making AI more adaptable and user-friendly. Whether you're a student, a business professional, or just someone who loves learning, these tools are becoming smarter, faster, and more intuitive. Want to see how these labels work in action? Stick around. We're about to dive into real examples of how this system transforms raw data into powerful AI insights.